In October 2017, a single AI system did something no one had managed to predict. It became the undisputed best player in the world at chess, Go, and Shogi, all three, within 24 hours of being turned on. It had never seen a game before. No training data from human matches. No openings database. It started from absolute zero, played itself through the night, and by morning it had surpassed every grandmaster, every champion, every player who had dedicated their life to a single game. The name of that system was AlphaZero, and what it discovered in those hours has since reshaped how we think about intelligence itself. Here is why that should concern you right now. The techniques AlphaZero pioneered were not locked inside DeepMind's servers. They spread. Within 3 years, systems built on those same foundations were being deployed in domains that have nothing to do with board games, drug discovery, materials science, financial modeling, military logistics. In 2025, DARPA confirmed that AI planning systems derived from AlphaZero's reinforcement learning architecture were being used to optimize battlefield resource allocation in live operational contexts. That is not a research paper. That is active deployment. Meanwhile, in poker, a game of hidden information that experts long considered the final human fortress, an AI called Libratus had already cleaned out 4 of the world's top professional players in Pittsburgh in 2017. Winning the equivalent of $1.7 million in chips over 20 days. These two events, separated by months, together mark something permanent. The moment machines stopped needing human knowledge to surpass human performance. The gap has only widened since. By 2026, the systems descended from both lineages are running at scales that would have seemed fictional a decade ago. Understanding what they actually did, and how, is not optional anymore. To understand what makes AlphaZero genuinely shocking, you need to understand what came before it. For decades, the dominant approach to building game-playing AI was brute force. IBM's Deep Blue, which defeated Garry Kasparov in 1997, evaluated 200 million chess positions per second. It did not understand chess the way a grandmaster does. It simply searched more possibilities, faster than any human could. That worked for chess because chess is a game of perfect information. Both players see the entire board. Go is considered immune to this approach. The branching factor, the number of possible moves at any given point, is so large that even searching a tiny fraction of it is computationally impossible. There are more possible Go positions than there are atoms in the observable universe. Think about that. A number so large it exceeds physical reality. Earlier Go AIs were so weak that amateur players routinely beat them. Then DeepMind's AlphaGo used a combination of deep neural networks and human game data to defeat world champion Lee Sedol in 2016. That was stunning, but it still relied on human games as a teacher. AlphaZero removed that entirely. No human knowledge. No prior games. Just rules and time. What AlphaZero actually discovered inside those 24 hours is the first revelation that stops most experts cold. When researchers analyzed its chess play afterward, they found it had independently reinvented several opening strategies that took human players centuries to develop. The Sicilian defense. The King's Indian. Structures grandmasters had refined over generations. AlphaZero arrived at them on its own, in hours. But it went further. It found moves no human had ever considered correct. Sacrificing queens early. Leaving pieces hanging for 10, 15 moves before the payoff materialized. Grandmaster Garry Kasparov, reviewing the games, said it played with a, quote, dynamic, almost human creativity, and then immediately corrected himself, because it was not human creativity at all. It was something else. Something that looked familiar from the outside but operated on entirely different logic. Stockfish, the world's strongest conventional chess engine at the time, lost 28 games to AlphaZero. It did not win a single one. In 100 games. What that result revealed is not just that AlphaZero was stronger. It revealed that strength and depth of understanding are not the same thing, and that machines had found a third path between brute force and human intuition. The deeper revelation is what happened when the same architecture was applied to poker, specifically to games with hidden information. Chess and Go are transparent. Every player sees everything. Poker is not. Your opponent's cards are concealed. Bluffing is not just allowed, it is mathematically essential. For years, researchers believed that mastering hidden information games required something close to human psychology, the ability to model another mind, to deceive, to read signals. Libratus, built by Tuomas Sandholm and Noam Brown at Carnegie Mellon, proved that wrong in January 2017. Over 20 days and 120,000 hands of heads-up no-limit Texas Hold'em, It beat 4 of the top poker professionals in the world by a margin so large the result was statistically unambiguous. Professional player Jason Les said afterward that Libratus bluffed in ways that were impossible to counter, not because it was unpredictable, but because its bluffing frequency was mathematically calibrated to make calling or folding equally bad. It had solved the game theory of deception. Sandholm's team later revealed that Libratus improved its own strategy overnight during the tournament, identifying leaks the professionals were exploiting by day and patching them by the next morning. It was adapting in real time to human attempts to beat it. That had never happened before. The mechanism behind both systems, stripped down to its core, is something called self-play reinforcement learning, and it works like this. You give the system the rules of the game and a simple reward signal. When equals good, lose equals bad. Nothing else. The system then plays against itself, millions of times, updating its internal model of what good play looks like based purely on outcomes. Think of it as evolution compressed into silicon. Instead of generations of organisms competing over millennia, you have versions of a neural network competing against each other over hours. The counterintuitive part, the part that surprises even experienced researchers, is that starting from zero is actually an advantage. Human training data carries human biases. It teaches the AI which moves are considered good by humans, which implicitly rules out moves humans never thought to try. When AlphaZero had no human data, it was free to explore the entire space of possible play, including the regions humans had collectively decided were not worth visiting. That is where it found its most devastating ideas. The neural network itself is evaluating positions holistically, the way a grandmaster does, not searching through millions of branches the way Deep Blue did. It is pattern recognition at extreme depth, trained not on what humans know, but on what actually wins. The complications arrive quickly. The first is interpretability. Nobody fully understands why AlphaZero makes the moves it makes. Its neural network contains hundreds of millions of parameters, and when it sacrifices a piece on move 12 to win on move 34, no one can extract a clean logical explanation from the network itself. This is manageable in chess. It is not manageable when the same architecture is used to make decisions about drug dosages, credit allocation, or military targeting. The second complication is access. DeepMind is owned by Alphabet, Google's parent company. Carnegie Mellon's poker work was partially funded by agencies with defense interests. The systems that emerged from this research are not open and distributed. They are concentrated in a small number of institutions with enormous resources. A third complication, less discussed, these systems are brittle in specific ways. AlphaZero, despite its dominance within the rules of chess, cannot handle a rule change it was not trained on. Genuine novelty breaks it. The intelligence is deep but narrow, and the gap between narrow and general remains large, though it is closing faster than most researchers predicted 3 years ago. What does any of this mean for you specifically? If you work in any field that involves optimization, logistics, legal strategy, financial trading, drug development, engineering design, the underlying technology of AlphaZero and Libratus is already inside the tools being built for your industry right now. McKinsey estimated in early 2026 that 40% of tasks performed by strategy consultants can be automated using reinforcement learning systems within 4 years. Lawyers who specialize in contract negotiation, traders who work on option strategy, engineers running materials simulation, all of them are looking at tools that will do in minutes what currently takes weeks. The actionable thing to watch for is not the replacement